Hi guys, and welcome to today's video on families of straight lines. Now, who would have thought that families and straight lines would go together? I don't know, is there a mummy straight line, a daddy straight line? I couldn't resist it. These puns, I promise you, do not get any better, and you'll probably know that if you are a long-term subscriber. Now, before I get into the excitement of families of straight lines, and if you think this video is going to be exciting, you are seriously deluded. It's maths! How's it going to be exciting? But if you are new, can you do me the greatest of honour? It is lovely having you here. And whether you know it or not, I'm not surrounded by thousands of people making a very, very beautifully slick production. It is actually just little old me trying to do a very big job on my own. So your support is greatly appreciated. If you can click that red arrow over there that says something along the lines of show me some support by subscribing, that'd be greatly appreciated. It just means I know that you are watching and that actually I'm doing this for a reason. Now, families of straight lines. I have this overwhelming need to break into song, but I might resist it for this moment in time. Now, what I want you to know by the end of the lesson, well, it is aboveth me, and basically what it means to have a family of straight lines, and basically what the three families that we are going to deal with are for this course. Now, if you're saying course, what course? Huh? I only logged on because you seemed a bit weird. No, I know that, that's fine. Basically, we're following the Methods 1 and 2 course over here in Australia, but maths is universal, and so I promise you that what you learn in this video, if you are in any other country, will be relevant to it all. Now, we are nearing the end of this section of work. Yay! The crowd goes crazy and everyone goes, I thought you said this stuff was hard, Darren. Yes, I did, but not so much now, it would appear. We've been looking at gradient, intercept form, straight lines, and so I suppose let's kick in to what we mean by a family. Now, actually, when we looked at the equation y equals mx plus c, so when we had the equation y equals mx plus c, the x and the y value were effectively coordinates, and what it said was there was some sort of relationship. So if I had y was equal to 2x minus 3, there is some sort of relationship that if I give an x value, then I multiply it by 2, I subtract 3, and I get a y value. And we know, because we've done this for years, that coordinates and Cartesian planes and axes and graphs are effectively nothing more than a collection of x and y values put together as a coordinate, or in Methods 1 and 2, an ordered pair. How exciting. The funny thing is, though, there are things that can change, and these are called variables. And m is one of those, and c is one of those. And that's what creates a family of curves. When we change the value of m, and we only change the value of m, we leave the c value the same, then we get one family of curves. If I was to leave m the same and change c, I get another family of curves. And that's what this video is going to do now. So, looking at the family 1, as I call it, we have y equals mx. Now, m is called a parameter. I was about to say pronumeral, but it isn't. M is a parameter, and we'll come to that a little bit later on, but that's the value I'm going to go and change. What happens if I keep changing the value of m? Well, I have a great little software package called desmos.com, and as we can see, there is Desmos loaded up for me. Now, I've already set up my equation, as you can see on the left-hand side of your screen, that basically has the equation y equals mx, and then I've put a slider in that can change the value of m. Now, if I use my cursor or my little thing to change the value of m, what we notice is that as the value of m goes negative, I get, well, obviously a negative line, because we know that m is gradient. And as I shift it and get it closer and closer to 0, it flatlines, beep, and then goes positive. Obviously, what is happening is, do you notice what the intercept is? Well, the intercept stays at 0 because we've fixed that. Y equals mx is really y equals mx plus 0. Yes, so the intercept stays at 0, and all we're doing there is changing my gradient. So that is family number 1. Then we move to family number 2. I don't see this video is going to last very long, ladies and gentlemen, but now I've got the situation where I'm saying, well, y is equal to 2x plus c. Now, in this situation, c is going to be my parameter. C is going to be the thing that I'm going to change, that variable that I'm going to alter. But we notice now that my gradient is equal to 2, so it has a fixed gradient. And I'm fairly sure every one of you out there watching now is going, I'm going to switch this off. This is what? This is part of the course over in Australia? Yeah, I know. Random, huh? But the idea is I've set this up and we can have a look and see what happens. So there we go, ladies and gentlemen. We have my graph all set up and I've got y equals 2x plus c. We can see that on the left-hand side of the screen. And I've said, well, let's just change the value of c. And if I move my value of c up, now it looks like the graph is actually moving to the left, but it isn't. It's actually moving up. Yes, I suppose in a way it's moving to the left as well, but the graph is actually moving up and down my y-axis because we know that the value of c is nothing more than my y-axis intercept. So, ladies and gentlemen, very visually, very exciting there. What do we see? Yes, that is a family of graphs too, because we're changing the y-intercept, but not the gradient. And the excitement grows even more. Why? Well, because I can now combine the two. So if I had y is equal to, in this situation, mx plus 1, and the great thing about these family graphs is we're looking to only change one thing. And so we're going back to say, well, let's change my gradient, but let's fix my intercept at a different point. Now I've chosen plus 1, could be any value at all. And you're going to turn around and go, okay, and what are we doing with this? Well, loading up desmos.com. Once again, I've got my y equals mx plus 1 set up for me, and I've got a slider in. And so what should happen is this now pivots around that value of 1 because the only thing I'm changing is the gradient. And ultimately, that's very much the three families of graphs that we need to know for this particular section of the textbook. So I suppose, why is it important? Well, actually, while we just dealt with straight line graphs there at this moment in time, there are huge numbers of functions you're going to be dealing with in methods 1 and 2 that also belong to families of graphs. So there will be hyperbolas and truncus, and there will be square root graphs, there'll be parabolas, there will be cubics, there might be quintics, there is cube root graphs. All of these graphs you actually have to know and be able to move around on the graph or the axes and be able to actually sort of manipulate in a way that the question asks you to do. So knowing that things are parts of families is awesome. Now remember, a family is really just taking a graph and moving it around. So any graph you take that's moved around is part of a family of graphs. Now, as I say here, for all of the equations we had above, n was known as the parameter. I would argue that c was also the parameter as well, but how can this actually be applied to questions? Well, all the questions in this section, I believe, are extracted from the Cambridge Essentials textbook series. And it is a great, great resource. And thank you very much to Cambridge for allowing me to use their textbooks. So the question here says, find the value of m, okay, find the value of the parameter, if y is equal to mx plus 2, and it passes through the point 311. Now, I can guarantee you there are a significant proportion of this country and probably the world who will look at that question and go, I can't find m. And I think the biggest trick questions ever use is they give you a coordinate and hope that you realize that's just code for an x value and a y value. A coordinate is nothing more than an x value and a y value. So wherever I see an x and a y in the equation, I bang those values in. So we now know y is 11. I don't know what m is. I know that x is 3. I'm going to put it in brackets and plus 2. And lo and behold, the question now becomes relatively trivial. And it's a shame because, as I say, so many people would miss what the significance of that coordinate actually is. So take away 2 from both sides gives me 9 is equal to 3m. And so m in this situation is equal to 3. Now, that was relatively simple. There are more complicated examples as it tends to build up. And so here is another question. It's a 3-parter. And it says, right, a family of lines have equations of the form y equals mx plus 2. Okay, I'm sure we've just done that one, but that's fine. Where m is a negative number. Oh, important. Find the x-axis intercept of a line in this family in terms of m. Now, whenever I see x-axis intercept, the first thing that goes into my head is, I know that y is equal to 0. So I'm using those keywords to translate it into maths that's going to be important to me. So I now know I'm going to substitute y is equal to 0 into that equation. So 0 equals mx plus 2. Take away 2 from both sides. Gives me mx is minus 2. And what does it want? Find the x-axis intercept of a line in this family in terms of m. Now, when it's in terms of m, it wants m in the equation. So I'm going to divide both sides by m to give me minus 2 on m. And there we go. Now, is that my x-axis intercept in that form? No, it is not, because an x-axis intercept must be written as a coordinate. So it'd be minus 2 on m, comma 0. And there's my answer. Now, it's perfectly acceptable to leave equations and answers in terms of letters. We've moved on now from the easy stuff, which were all numbers. Now we've got to get used to doing letters. Okay, so this next part of the question says, for which values of m is the x-intercept greater than 3? Well, okay, so we've got to be greater than 3, and we know what my next x-axis intercept is. So we know it's minus 2 on m is greater than 3. Now, here is a massive trick. When we go back to the original question, we have to notice that m is a negative number. And if you don't pick up on that, I'm afraid this is where we crash and burn. Now, how do I know this? Well, because I've just crashed and burned for the last 3 minutes. Because I'm like, I don't get what is going on here, because I kept getting a value that was wrong. But m is negative. And if remember, we're now going to get rid of that divide by m by timesing by m on both sides. And because m is a negative number, when you multiply it or divide by a negative, what do you have to do? You flip the inequality. Ooh, Barry, you are so tricky. And so that becomes -2 is less than 3m, and then dividing both sides by 3. Now 3 isn't negative, so I don't have to re-reverse my inequality. I get that -2/3 is less than m, or m is greater than -2/3. Is that my final answer? No, because the question says for which values of m. We have to give a range of values, and m has to be negative. So if m's going to be greater than -2/3 and still negative, then we know my solution set would be -2/3 is less than m is less than 0. All right? Awesome. Fabulous. But tricky because that m was negative. Oof, annoying. Find the equation of the line perpendicular to the line y equals mx plus 2 at the point 0, 2. Right, perpendicular. I've seen that. I want the equation of a line. So I'm going to do y minus y1 equals mx minus x1. Ooh, this is exciting stuff. So we've got my coordinate position, which gives me my x1 and my y1. So I'm going to substitute that in. Y minus 2 is equal to mx minus 0. Oh, thank you very much. So simplifying that for the moment, I haven't finished my question, by the way, because I want the gradient that is perpendicular to that line. Well, what's the gradient of that line? It's m. And so how do I find the perpendicular gradient? I reciprocate it and change the sign. So my gradient that I want is equal to -1 on m. Now that's really confusing because I've got two m's in that situation. Notationally, probably want to choose something else to write. But my point here is that y minus 2 now becomes -1 on m times x. And so rearranging that gives me -1 on mx plus 2. Now, believe it or not, that type of answer will confuse so many people because they'll go, well, is that right? And that's part of methods. You have to take a punt. You have to go, yes, I believe that's right, because a lot of your answers now are literally going to end up as letters and pronumerals and numbers, and it's all going to look gross, but you have to have some confidence in what you're doing. And now actually with that question, it was no different from all of the theory we've already learnt. It's just being applied in different ways. It's trying to use language that's going to trick you. And I say to you now, Barry has done himself proud for methods 1 and 2 because it's all in the language. The actual work, I promise you, is really, really easy or basic. It's how it's applied in the algebra that tends to throw people. All right, I'm done. Thank you so much for taking the time and watching. I am delighted to see you here. If you haven't already done so, can you do me a favor and subscribe by clicking that circly thing there? And if you're really not going to subscribe, wow, you're a tough cookie. If you can do me the honor, please, of maybe watching the next video, which is loading over there as well on a very similar topic. It's good to see you. Thank you very much. Take care. Have a good day. MaffsGuru out.